morning, chaps. Week number 10, term 2. And I'm hoping you guys are going to be next in line to come here. Chaps, we are continuing in our big topic of Euclidean. We've done quite a lot of work last week on, congruency. I've done already one lesson before that. This is, if things go according to plan, this is already the second lesson of this week. So we already had one lesson, and that was to finish up congruency. We're moving to similarity. Okay, so all this week is about similarity. What do similar triangles, similar polygons mean? So I drew 3 triangles. Okay, we've got triangle ABC, DEF, GHI. Now, let's start with what we know. What congruency we have here? Which triangles are congruent? And you can probably say, without looking too much, that the 2 triangles on the right are congruent. Let's write that down, okay? So triangle EDF is congruent. That's how we write congruent. That's like triple equal. Congruent. And now it's very important to write down the correct order. So angle E is equal to angle H. You can see they're both 30. Okay, so I've got to write H. I wrote the second one was D. So this is 80, that is 80. So it's G. And then I've got I. So triangle EDF is congruent to AGI. Okay, the angles are the same. Okay, the angles are the same. 30, 30, 80, 80, 70, 70. But also the sides of the triangle are the same. So this is 1. This is 1. This is 1.5, 1.5, 0.5, 0.5. Remember, we had this whole thing that if you write the right order, then you'll see that ED is equal to AG. ED is equal to AG. Okay, good. We're not going to carry on. That's what we've done last week. What is similar triangle? If these are congruent triangles, what about similar triangle? Well, if I look at these 2 triangles, okay, they're obviously not congruent. They're not the same, okay? This is bigger. And if you can look at the numbers as well, if this is, let's say, 1 centimeter, this is 2. Okay, so they're not congruent. But you can probably understand what I'm saying when I say they are similar. Okay? It's kind of like this triangle. We took this triangle and we expanded it. Okay? And how do I know for sure? I look at the angles. Check this out. If this is 30, this is also 30. This is 80, this is 80. This is 70, this is 70. So they're not congruent, the triangle, but they are similar. Let's write that down, okay? So triangle, I'll start here, BAC. BAC is similar to triangle. Again, I got to write down the right order because angle B is equal to angle E. So I'm going to start with E. Angle A is similar to or equal to angle D. And then the last one of that, EDF. So these 2 triangles are similar. It means that they're not identical. The sides don't have the same length, but the angles are the same. Okay? And how do we write similar? Okay? If this was congruent, okay, this sign means congruent. Okay? Similar, it's like this, but it's just turned upside down. Not upside down, sideways. Okay? 3, like a triple equal sign, but turned, standing on its head. That means similar. Okay? Now, what really similar triangle means? It means 2 things when it comes to triangle. It means either the angles are the same, which we saw that 30, 30, 80, 80, 70, 70. But there's one more thing that I didn't really mention. Okay? Another thing that needs to happen is that the sides have to be in the same ratio. What does that mean? The sides are not the same. Okay? ED, okay, if I draw this ED here, that is not equal to AB. Okay, this is 1, this is 2. But if we look at, let's find the ratio between them. So I'm going to do AB over ED. AB over ED. Okay? Right? What is that equal? That is equal to 2 over 1. 2 over 1. Now let's have a look at another side. Okay? Let's have a look at BC. And therefore EF. Okay? Let's see if they're equal. So BC is 3. And 1.5. Obviously, they're not the same. But if I find the ratio, 3 over 1.5 is 2. Just like 2 over 1 is 2. That's interesting. Okay, let's try one last side. AC. AC and DF. AC is 1. DF is 0.5. 1 divided by 0.5. Can you do it without a calculator? 1 divided by half. That is 2. You're noticing something here. Okay? The sides are not equal. 1 and 2, 0.5 and 1, 1.53. They're not equal. But they have the same ratio. If we divide this side by that side, or this side by that side, or this side by that side, you get the same number. Okay, so as I started saying, similar triangle, two triangles that one is like a magnification of the other. The angles are the same, okay, and the ratio of the sides are also the same. Okay? That's also true for any kind of shape. You can do shape with 4 sides, 5 sides, 100 sides. Okay? Similar shapes means that they have the same angles and the sides are in the same ratio. But we're only going to work with triangles. And the reason is, okay, I don't want to get into too much details, but when it comes to, let's say, a 4-sided shape, to prove that they're similar, I need to prove that the angles are the same and the sides are in the same ratio. Okay, you have to prove both of them. But it turns out that in triangles, they're special. You only need to prove one or the other. So to prove that similar triangles are similar, you either need to prove that they have the same ratio between the sides or that they have the same angles. Okay? So today, what we're going to do in the second part of this video, I'm going to prove that the angles are the same. Okay? And then, therefore, we prove that the triangles are similar. In the next lesson, we're going to have to prove that the sides are in the same ratio. Okay, I'll pause and we'll go for our first example. Okay, chaps, so we've got our first example, but first of all, I really would like you to actually copy this thing in the red, and I'll read it for you into your book. That really is the most important thing for this topic of similar triangles. So what we're going to try and do is prove that triangles are similar. And we can do it in either one of 2 ways. Okay, just like for congruency, we had 4 ways. Remember, SSS, SAS, SS, all that stuff. For similar, there's only 2. So one, okay, to prove that triangles are similar, we need to prove that either one, the angles are equal. So you have 2 triangles, they have corresponding angles that are equal. Or, and it's or, so you don't need to prove both of them. You need to prove 1 or 2. The other option is that the sides are proportional. That means they're the same ratio. Okay, in this lesson, we're just looking at triangles. So pause me, copy that down, and let's move on to the example. So I've got 2 triangles, ABE, EDC, and I want to show that they're similar. Okay, and I already said it's all going to be about angles. So how am I going to prove that the angles are the same? So I need to just prove that angles are the same. Okay? So this is E1, okay, and this is E2. So the first step I need to say, okay, look, E1 is equal to E2. Okay, but remember, I must always give a reason. How do I know? Well, this shape, what does this thing mean? It means that they're both 90 degrees, right? That little square means that they're 90 degrees. So I'm just going to write given. It's just given. What's the other pair of angles that are the same? You can see there's a dot here and a dot there. So I can say angle A equal angle C. Okay? And again, the reason is given. Okay? Now notice what I'm doing here. I did mention that to you with congruency. I write all the angles of the small triangle, the one on top, on the left. And all the angles of the big triangle, at the bottom, on the right. So I know if at the end it will be easy for me to write the order of the letters for each of the triangle. So I've got 2 angles here, 2 angles here. I'm missing B and D. How can I tell for sure that angle B is equal to angle D? It wasn't given. It wasn't told to me. I get no information about these 2 angles. But if I got 2 angles on each triangle, which are the same to the other 2 triangles, the third one must be equal. What's the reason? Okay? Correct. Sum of angles in a triangle. Okay? Sum of right? If, just to give you an example, this is 90, and this is, let's say, 30, okay? So that means this is 90, and this is 30, okay? So 90 plus 30 is 120. That means this is going to be 60, right? Because sum of angles in a triangle. And here 1930 is 120, so this is also going to be 60. So you can see that if I've got two pairs of angles which are equal to each other, the third one also must be equal to each other. Okay? Right, so now I just need to say that the triangles are similar. Here the tricky part comes. I need to write down the order of the triangles, but I'm going to show you a trick. If I was very careful and I wrote all the angles of the triangle on top on the one side and all the angles of the other triangle on the right side, now I can just copy. I can say, okay, the triangle here is E, A, B. See, I'm just reading it. E, A, B. I don't need to write E1. E1 it was just to make it different to E2, but it's still E. So E, A, B. In this case, I can write similar. Okay, similar. Oh, I want to just make sure you guys see this. Okay. Okay. EAB, and now I just need to write it from this side. Okay, that's going to be similar to triangle ECD. Okay, why is that going to work? Because now I know E1 equal E2, A is equal to C, as you can see here, and B is equal to D. That's why it's very important to write things in the right order. All the triangle on one side and the other triangle angle on the other side. And now I have to write the reason for that. And the reason for that is corresponding angles. I'm just going to use of the two triangles are equal. Okay? Right? The corresponding angle. Corresponding, let me just pause it for a second. Okay. Now you can see. Okay, so it's very important. These are not the corresponding angles from a parallel lines. That's not these corresponding. Corresponding means that this corresponds to that, this corresponds to that, this corresponds to that. It's not, there's no parallel lines here. Okay, don't get confused. So, but that's the reason that you need to be able to state when you prove that similarity. Corresponding angles of the two triangles are equal. Okay, and that's it. We proved it. Okay. I'm just going to see if there's any more examples we should go through. So just hang on there. Okay, so one more example. Now I can see that the lesson are not as the one as exactly I imagined. So I'm going to show you another example, which actually a way of proving that triangles are similar, not using angles. So both ways that we're going to see in this lesson. Okay, but all the questions that are in the exercise, we by the way doing exercise 8. Okay, I'll write down that. Exercise 8 on page 168. So all the examples there are pretty easy. Next lesson will be just more difficult. So we've got two triangles and we want to prove that they're similar, but now you can see I don't even have any angles. There's no angles. These are sides. Okay, that's 5 centimeters, 3, 4, 8, 6, 10. I don't have any angles, so don't even think about proving that the angles are equal because we just don't have any information. But we said the second option to prove that triangles are similar is to prove that the sides are proportional. The corresponding sides are proportional. So have a look at this. This is the small triangle, this is the big one. 3 and 6. We doubled it, right? 4 and 8. We doubled it again. 5 and 10. We doubled it. So here we go. Okay, we have one triangle which is basically double the other. So how do I write it? How do I write it in words? This is how you do it. You say, okay, look, DE divided by AE is 6 divided by 3 is 2. Okay? And you're going to just write down a reason. Okay? A reason is obviously given. Okay? Hope you can see it all there. Okay. Next one, I've got DE and AE. Next one, I'll do EC over AE. AC over AC over BE. EC over BE. AC over EE is 8 divided by 4. Again, given. Okay? Now, I should write here, but I don't want to run out of space, so I'm just going to move over there. Okay? Last side, we showed two ratios of two pairs of side. Okay, this is obviously also equal to. Okay? Now I've got to find this one. So it's going to be that and that. So DC over AB. That is 10 over 5, which is 2 as well. The reason is given. Okay? Now, if these two sides, the ratio is 2, these two sides, the ratio is 2, this side is the ratio is 2, then we can write, therefore, I can say DE over AE must be equal to EC over BE, because they're all equal to 2, right? And that's also equal to DC over AB. Okay? That's just what we showed now. Okay? So what we're showing here is that all these pairs of sides, DE over AE equal EC over BE equal DC over AB. Therefore, I can now write down the triangles that are similar. Okay? And I got to be careful here. Okay? I got to write the right order. So I'm going to start with E. E. Okay? How shall I do that? ED triangle. So I better write triangle. Triangle EDC. EDC is similar to triangle. Now I have to be careful. If I went from E to D to C and ED is 6, which is double EA, then I have to start. If I start from E, I must go to A to B. Okay? Because what we know, what do we have to make sure? We got to make sure that ED is double EA. ED is double EA. Yes, 6 is 3 double 2. DC must be double AB. DC must be double AB. It is. And EC must be double EB, which works as well. Okay? And again, we need to write down a reason. Okay? The reason really needs to be written here, but I ran out of space. Okay? And the reason, I'm just going to use what the book says. Corresponding sides, okay, in proportion. In proportion. P-R-O-P, proportion. We just make a little shortcut. Okay? So corresponding sides are in proportion. Okay? They're all double. 8 is double 4. 10 is double 5. 6 is double 3. That means that they're all in proportion. Okay? They have the same ratio. That's it, guys. You can do exercise 8. These are simplerish questions. You should be able to figure it out. I'll see you guys in the next question, next exercise, which is a bit more difficult.